Imagine the stars fading one by one. Imagine the final breath of the universe. What remains when time itself disappears? This isn't just the end. It's silence stretched across eternity. Stay with me and witness how everything unravels. The heat death. Imagine standing on the edge of time, gazing into the universe's vast expanse. The stars are shining. Planets are rotating. Galaxies are colliding. And life is thriving. This is what we experience now, an active universe full of energy and motion. But imagine a time, billions of years from now, when none of this exists. A time when the universe, once full of stars, energy, and life, has gone silent. This is the concept of the heat death of the universe, the ultimate end of everything. In the distant future, stars will burn out one by one. The incredible fusion processes that power these cosmic giants will eventually come to an end. As stars run out of fuel, they will either collapse into dense remnants like white dwarfs or explode as supernovae, leaving behind black holes or neutron stars. But even these eventually will meet their end. Black holes, which are the most powerful objects in the universe, will slowly evaporate over the course of trillions of years through a process known as Hawking radiation. As the universe continues to expand, the distance between stars and galaxies will grow larger. Gravity, which once held everything together, will lose its grip, and the universe will become increasingly isolated. The once dense clusters of galaxies will drift apart, each far from the other, unable to interact. The galaxies, once shining with billions of stars, will become dark, empty shells. Over time, stars will cease to be born, and the energy needed to create new life or spark new events will be gone. What happens when there is no more energy, no more heat, and no more motion? Entropy takes over. Entropy is the tendency for energy to spread out evenly across a system, moving from areas of high energy to areas of low energy. This process continues until everything is evenly spread out and no more work can be done. In this state of maximum entropy, the universe will be a vast, cold, and empty void. With no energy, life, or even the possibility of new events occurring, the universe will be locked in a state of absolute stillness. There will be no light, no heat, no sound, just an endless stretch of dark, cold space. Even the remnants of stars and black holes will fade away into nothingness. Eventually, the last atoms will disintegrate into pure energy, leaving behind a universe that is devoid of life, movement, or change. Time itself will lose its meaning. There will be no way to measure the passage of time in a universe where everything is frozen, unchanging, and lifeless. The heat death represents the final chapter in the universe's story. Not a violent or cataclysmic end, but a quiet, gradual fading into oblivion. It's a concept that challenges our understanding of existence. We often think of death as a sudden event, but the universe's demise will be drawn out, slow and inevitable. There will be no explosions, no dramatic collapse, no last moment of struggle. Just the slow cooling and fading of everything that once was. As humans, we tend to see the universe through a lens of constant change and possibility. We live in a time of great discovery, where new technologies are opening doors to previously unimaginable realms. But the heat death reminds us that all of this is temporary. Everything, no matter how grand or monumental, will eventually fade. The civilizations we build, the stars we gaze upon, and the galaxies we explore will one day cease to exist. The universe as we know it is a fleeting moment in the grand scale of time. And as we ponder this eventual fate, we must ask, does this mean the universe itself is doomed, or can we find a way to transcend this fate? Can we, as a species, push beyond the limits of entropy? Or will we too become a part of the quiet, inevitable stillness that awaits all things? How do you feel about this eventual end? Do you think there's any hope for the universe, or is the heat death an inescapable truth? The Big Rip imagined the universe as a gigantic balloon, stretching and expanding over time. Right now, we are just tiny specks in this vast, ever-growing cosmos. We look at the stars and galaxies, and it seems as if everything is staying the same. But in reality, the universe is expanding, and it's expanding faster and faster. This phenomenon is known as the Big Rip, and it's one of the most mind-bending and unsettling theories about the universe's ultimate fate. The Big Rip is tied to a mysterious force known as dark energy. This invisible energy is believed to be responsible for the accelerated expansion of the universe. Since the 1990s, scientists have observed that distant galaxies are speeding away from us at an increasing rate. Initially, it was thought that gravity would eventually slow down the universe's expansion. But dark energy has proven to be much more powerful, pushing galaxies, stars, and even individual atoms apart. As the universe continues to expand, galaxies will move farther away from each other, making the night sky darker and emptier. But the Big Rip doesn't stop there. The real devastation begins when this acceleration starts to tear apart not just galaxies, but the very fabric of space itself. The force of dark energy will become so strong that it will eventually overcome all the fundamental forces of the universe, including gravity, electromagnetism, and even the strong nuclear force that binds atoms together. In the final stages of the Big Rip, stars will be torn from their galaxies, and planets will be pulled away from their stars. The very structures that make up the universe, the stars, planets, and even black holes, will be stretched and torn apart, piece by piece. It will be as if the universe is unraveling, like a thread slowly coming loose. Nothing, not even the most fundamental building blocks of matter, will be immune to this force. Atoms themselves will be pulled apart, breaking down into their individual particles, and eventually, even the subatomic particles will cease to hold together. The moment when the Big Rip reaches its peak is unfathomably chaotic. All the energy in the universe will be in motion, each force and particle striving to break free from the others. Space itself will stretch to its limits, and even time may cease to have any meaning. The very essence of reality as we understand it will be shattered beyond recognition. The universe will be torn apart in a violent and unstoppable process, ending not with a slow, silent death, but with an explosive, cosmic unraveling. This catastrophic event would occur in the distant future, but it's not as far off as you might think. Some estimates suggest that it could happen in about 22 billion years, a relatively short time on the scale of the universe's age, but a terrifying one in terms of the total annihilation it promises. It is a fate that offers no escape, no survival, and no hope. Once the Big Rip begins, nothing can stop it. The Big Rip is the opposite of the heat death. While the heat death envisions a cold, lifeless universe in a state of maximum entropy, the Big Rip suggests that the universe will meet its end in a dramatic and violent disintegration, where everything is torn asunder by the very forces that once held it together. It's a reminder that the universe is not a static entity, but a dynamic system that is constantly changing, and its future may be far more chaotic than we can imagine. As you consider the possibility of the Big Rip, think about the force of dark energy that's slowly stretching the universe apart, and wonder how long it will take before the universe reaches the breaking point. Is there any way to stop it? Or is the Big Rip just as inevitable as the end of the stars? What do you think? Could the Big Rip truly be the universe's fate, or is there hope for a more stable end? Share your thoughts in the comments below. The last star. Imagine standing alone in the vast emptiness of space, surrounded by nothing but an eternal, impenetrable blackness. There are no stars, no light, no warmth. This is the haunting reality that the last star proposes. A future where the universe has reached its ultimate death, and all the stars that once illuminated the cosmos have exhausted their fuel and faded into oblivion. For billions of years, stars have been the defining feature of the universe. Their light has guided us, provided energy, and been the foundation for life itself. But just as all things in the universe are born, they too must die. Stars are massive, glowing balls of gas that generate heat and light through nuclear fusion. They are born from the collapse of clouds of gas and dust, and they live for billions of years, burning through their fuel to create the radiant energy that we see as starlight. However, even the brightest stars eventually run out of fuel. The idea of the last star suggests eventually all stars will die. The larger ones will explode in violent supernova, leaving behind remnants like neutron stars or black holes. Smaller stars like our Sun will slowly burn out, shrinking into white dwarfs, cold and lifeless remnants of their former selves. Over time, all stars, no matter their size or type, will eventually burn through their fuel. But the most profound event will be the moment when there is no new star formation. The universe is constantly expanding, and with this expansion, the gas and matter necessary to form new stars becomes more and more sparse. Eventually, the raw materials needed for the birth of new stars will be scattered too thinly across space. This means that no new stars can form, and the stars we currently see in the sky will be the last ones. As these stars burn out and die, the universe will be plunged into darkness. The light that has illuminated the night sky for eons will vanish, leaving behind an empty, silent void. This event will unfold over unimaginable spans of time. We're talking about billions and billions of years before the last star flickers out. But once the last star dies, what happens to the universe? The first thought might be that the universe will continue expanding, but with no stars to fuel it, it will become cold, dark, and devoid of life. The void will be all-consuming, and energy will be nothing but a distant memory. Without stars, planets will freeze, and even the remnants of stars that once existed will cool down, becoming dark, lifeless husks. Here will be no light, no warmth, and no energy left in the cosmos. It's a chilling thought. A universe where nothing moves, nothing grows, and nothing exists in the way we know it. But the death of the last star raises a bigger question. What does this mean for the universe itself? Is the death of the last star the true end of everything? Will the universe simply continue to stretch out into infinity, forever dark and cold? Or is there a deeper mystery waiting to unfold, something that goes beyond the end of stars? The theories vary. Some suggest that after all the stars die, the universe might enter a state of perpetual stagnation, unable to create any more life or energy. Others wonder if there's a force in the cosmos that will somehow reignite the universe, or if perhaps there's something even stranger waiting to emerge from the darkness. The death of stars is not an ending that we can fully comprehend, and that is part of the mystery. It's the ultimate finality. As we ponder the death of the last star, we're confronted with the reality that all things in the universe are impermanent. Everything, even the brightest lights in the cosmos, eventually fades. It's a sobering reminder of the transience of life, the inevitability of death, and the cold, impersonal nature of the universe. But perhaps the true meaning of the last star is not just the physical death of a star, but the deeper reflection on our own mortality and the fleeting nature of time. The universe will continue, but in a form that is so foreign to us, it's hard to imagine. Let's think about this. If there are no stars left, if the universe is reduced to nothing but dark, empty space, what will become of us? What will become of the world we know? It's a question that puts life into perspective. If the stars can die, so too can everything else. Yet, it's this realization that brings a new sense of urgency to the present. It reminds us that we must cherish the light while it's still here. The Black Dwarf Era. Imagine a universe where the stars have long since burned out, their brilliant light reduced to mere whispers in the fabric of time. Now, the cosmos has entered the era of the black dwarfs, the silent remnants of once vibrant stars. After billions of years, the remnants of stars that once burned with intense heat will cool, solidify, and fade into the void, leaving behind cold, dark remnants scattered across the universe. But what exactly is a black dwarf? To understand this, let's take a moment to look at how stars evolve. When a star like our Sun reaches the end of its life, it sheds its outer layers and transforms into a white dwarf, a small, dense object that no longer undergoes nuclear fusion. Over time, this white dwarf continues to cool and fade, unable to reignite itself. It slowly loses its heat and light, gradually becoming colder and colder until it reaches a temperature so low that it ceases to emit any light at all. It is in this state that the white dwarf becomes a black dwarf, an inert, frozen corpse of a star that no longer shines. The process of a star becoming a black dwarf takes an unfathomably long time. In fact, it is believed that no black dwarfs exist yet, as the universe itself is not old enough for stars to have cooled down enough to reach this state. But eventually, as the universe ages, all the white dwarfs will cool down, and they will all become black dwarfs. Imagine the scene. A universe where, instead of the fiery glows of stars scattered across the sky, the darkness reigns supreme, broken only by these faint, frozen remnants of a once luminous past. The Black Dwarf Era represents a period in the distant future where the universe is almost entirely devoid of energy. With all stars extinguished, galaxies will be scattered across an increasingly desolate universe, populated only by these frozen remnants. The light that once lit the night sky will be gone, and the only signs of past cosmic events will be the cold, dead black dwarfs drifting through space. Even the remnants of black holes will fade into the cold, empty universe, leaving only the slightest traces of their existence. But there's something haunting about the Black Dwarf Era. It is the final stage of stellar evolution, where there is no possibility for anything to be reborn. The universe will no longer be a place of growth, change, or creation. Everything that was once alive or radiant will have decayed into nothingness, leaving behind only the coldest of shadows. It's the ultimate symbol of entropy, where everything is on a slow path toward oblivion, with no chance of regeneration or rebirth. As we think about the universe entering the Black Dwarf Era, it's hard not to feel a sense of cosmic despair. The era is a reflection of the universe's inevitable decline, where time itself seems to stretch out in an unbroken, hopeless infinity. But paradoxically, it also speaks to the resilience of the universe as it continues to exist even in its most exhausted form. Even in a universe filled with nothing but cold remnants, there is a quiet, unspoken endurance that persists. The Black Dwarf Era might be the end of creation, but it also marks the universe's unwillingness to simply vanish completely. It is the final testament to the endurance of existence, even in the face of complete entropy. What can we take away from the Black Dwarf Era? It serves as a reminder that all things have their end, but more importantly, it challenges us to reflect on how we, too, must make use of the time we have while the light still shines. Just like the stars that once burned brightly, we have the power to shine, but we must also acknowledge that, in the end, everything will fade. Nothing is permanent, and everything eventually cools, drifts, and dies. Take a moment to think about the inevitable passing of time. The Black Dwarf Era shows us that nothing lasts forever. So how will you choose to live in the time you have? Phantom energy. As we venture deeper into the mysteries of the universe, there is a force that exists, unseen and ungraspable, driving the cosmos apart at an accelerating rate. This force is called phantom energy. While dark energy is the dominant factor behind the expansion of the universe, phantom energy is a more ominous and terrifying variant, one that is theorized to cause the universe to tear itself apart. The concept of phantom energy pushes the boundaries of what we understand about space, time, and the very nature of existence. Let's start with the basics. Dark energy was proposed to explain the unexpected acceleration of the universe's expansion. For a long time, it was believed that the expansion of the universe would slow down because of gravity. However, scientists were shocked to discover in the late 1990s that not only was the universe expanding, but it was expanding faster and faster, defying all expectations. This led to the discovery of dark energy, a mysterious force that works against gravity and pushes everything apart. But dark energy, while strange, remains relatively constant in its effects. Enter phantom energy, a more sinister force, far more potent than dark energy. Unlike dark energy, which remains a steady force, phantom energy's strength increases as time progresses. As the universe ages, phantom energy grows stronger, causing the rate of expansion to accelerate exponentially. While dark energy causes galaxies to drift away from each other at an increasing rate, phantom energy doesn't just drive them apart. It tears everything asunder, from stars to planets, to even the atoms that make up matter itself. This theoretical force intensifies over time, meaning the longer the universe exists, the more forceful the effect becomes. Imagine, if you will, a universe expanding at an ever-increasing rate. As galaxies pull away from each other, it is as if phantom energy is feeding off this expansion, growing more powerful, faster and faster. In time, not even the gravitational forces of matter will be able to hold structures together. Even the very fabric of the universe, the force that binds atoms and molecules, would eventually be overcome. This process, known as the Big Rip, is a terrifying concept. As phantom energy's influence continues to grow, the universe will be pulled apart at every level. Stars will be torn from their galaxies, galaxies will drift apart, and eventually the space between even the smallest particles will widen until there's nothing left. The very idea that everything, every star, every planet, every atom, could be ripped apart by an invisible force is chilling. What makes phantom energy particularly unsettling is that it is completely invisible to us. Unlike other forms of energy or matter, it has yet to be directly observed. Instead, scientists can only infer its existence by the effects it has on the expansion of the universe. And the more we learn, more terrifying it becomes. Phantom energy may not just be an accelerating force in the universe. It could be the very thing that drives the universe towards its ultimate and inevitable end. If phantom energy continues to dominate the cosmos, we could be witnessing the destruction of everything we know and understand. Not in a distant future, but in a way that seems entirely beyond our control or comprehension. The universe's ultimate fate might not be an orderly collapse or a gentle fade into darkness. Instead, it could be a violent, chaotic, ripping apart of the very fabric of existence itself. This concept invites us to think about the universe on a scale far larger than our understanding of time. Not only does it challenge our current models of cosmic behavior, but it also forces us to reconsider the stability of the universe as a whole. Is this our universe's endgame? Could the unstoppable force of phantom energy unravel the universe at its seams? And what does this mean for us in the grand scheme of existence? What do you think about phantom energy? Could it be the final force that reshapes everything we know? Hawking radiation. One of the most mind-bending concepts to emerge from the world of theoretical physics is Hawking radiation. This mysterious phenomenon was first proposed by physicist Stephen Hawking in 1974, and it changes everything we thought we knew about black holes. For years, black holes were considered to be nothing more than cosmic vacuums, devouring everything in their path without giving anything back. Not even light could escape their grasp. However, Hawking's groundbreaking discovery revealed that black holes are not entirely black. Instead, they are capable of emitting radiation, which means they can actually lose mass and energy over time, slowly evaporating into nothingness. At the core of this theory lies the concept of quantum mechanics, which governs the behavior of particles on the tiniest scales. According to quantum theory, even in empty space, there are constantly pairs of virtual particles and antiparticles popping in and out of existence. Normally, these particle pairs annihilate each other almost immediately after appearing, leaving no trace behind. But near the event horizon of a black hole, the incredibly strong gravitational forces distort space-time in such a way that these virtual particles are separated before they can annihilate one another. In this process, one of the particles may be drawn into the black hole, while the other escapes into space. The particle that escapes is what we call Hawking radiation. This radiation is composed of particles, such as photons or neutrinos, which are emitted by the black hole. This process causes the black hole to lose mass and energy over time. The more radiation it emits, the smaller and more diminutive the black hole becomes. But the implications of this are staggering. If black holes are constantly radiating and losing mass, they must eventually shrink and, in theory, disappear entirely, a process called black hole evaporation. This revelation challenges our understanding of the ultimate fate of black holes. The idea that black holes, once thought to be eternal cosmic objects that devoured everything, could eventually vanish and leave nothing behind is nothing short of revolutionary. Hawking, quote, discovery of radiation coming from black holes also has profound implications for the information paradox. According to classical physics, anything that falls into a black hole is lost forever, and no information about it can escape. However, if black holes can emit radiation, it raises a perplexing question. Can information be carried out of the black hole by Hawking radiation, or does it remain trapped forever inside? This paradox has led to decades of debate and research in theoretical physics, with no definitive answer yet. It touches upon the very fabric of quantum mechanics and how information behaves in the universe. Hawking radiation also suggests that black holes are not the ultimate death traps they once seemed to be. Rather than being eternal prisons, they are slowly but inexorably losing their mass, eventually fading away. However, this process takes an extraordinarily long time. For a black hole with the mass of our Sun, it would take on the order of 10 circumflex 67 years to evaporate completely, far longer than the current age of the universe. Despite this long time scale, the concept of black hole evaporation raises intriguing questions about the future of our universe. If the universe continues expanding, and black holes eventually lose all their mass through Hawking radiation, what will remain of the universe? Could the universe, in the far distant future, become an empty void, where the only remnants of its past are the radiation left behind by black holes? Hawking radiation forces us to confront the very nature of what black holes are and how they behave. It challenges the idea that black holes are simple cosmic objects with an insatiable hunger for matter. Instead, they may be far more dynamic and complex, engaging in a process of gradual decay that spans billions of years. Hawking's work reminds us that the universe is far more mysterious than we could have ever imagined. While black holes might seem like the most destructive and final objects in space, they are, in fact, part of a larger cycle of cosmic life and death. What do you think about Hawking radiation? Do you believe black holes can truly evaporate into nothingness? Quantum fluctuation. One of the most perplexing and bewildering ideas in modern physics is quantum fluctuation. This concept lies at the heart of quantum mechanics, the branch of physics that deals with the behavior of particles at the smallest, most fundamental level. Quantum fluctuation refers to the temporary, random changes in the amount of energy present in a point in space. These fluctuations occur even in what we consider a perfect vacuum, a space devoid of matter and radiation. In classical physics, we think of a vacuum as a space with nothing in it, an empty void. But quantum mechanics tells us that even in this empty space, the rules of the quantum world still apply. According to Heisenberg's uncertainty principle, energy cannot be perfectly constant. It will always fluctuate within a certain range. These fluctuations are incredibly small, but they have profound consequences. At every moment, pairs of particles and antiparticles spontaneously pop in and out of existence. These virtual particles can appear for a fleeting moment, then annihilate each other before they can be detected. However, their very existence influences the surrounding space, and they can leave an imprint on the larger universe. These quantum fluctuations are a key part of the zero-point energy that fills the vacuum. Now, imagine the role these fluctuations play in the larger scale of the universe. The randomness of these energy shifts has been proposed as a mechanism behind the Big Bang itself. According to one theory, quantum fluctuations in the very early universe were responsible for the small variations in density that eventually led to the formation of galaxies, stars, and planets. Without these fluctuations, the universe might have been uniform, with no structures to support the complexity we observe today. But the implications of quantum fluctuation stretch far beyond the birth of the universe. On the grandest scale, quantum fluctuations could also be responsible for the structure of the universe, influencing the cosmic landscape in ways we are only beginning to understand. These fluctuations can even contribute to the phenomenon of dark energy, the mysterious force that is driving the accelerated expansion of the universe. At a more fundamental level, quantum fluctuations also offer a glimpse into the nature of reality itself. If space and time are constantly fluctuating, how do we define the true nature of existence? These fluctuations challenge the classical idea that the universe is a steady, predictable place, showing us that at the smallest scales, the very fabric of reality is in constant motion, unpredictability, and change. The idea of quantum fluctuations also ties into the multiverse theory. In this view, fluctuations in different regions of space-time could give rise to entirely different universes, each with its own set of laws and constants. These fluctuations, if taken to their extreme, might create an infinite number of parallel universes, each one branching off from the other like an ever-growing tree. The Big Bang could be just one of many events, happening repeatedly in an endless cycle of creation and destruction. These quantum fluctuations seem like small, fleeting events, but their effects are far-reaching. They suggest that at the most fundamental level of existence, the universe is much more dynamic and unpredictable than we ever imagined. Far from being a calm, steady system, the universe is a boiling cauldron of energy, randomness, and potential, where everything is constantly in flux. The implications of quantum fluctuations on our understanding of time and space are both profound and unsettling. As we learn more about the quantum nature of the universe, we may come to realize that everything we take for granted, from the consistency of physical laws to the very idea of reality itself, may be nothing more than the result of constant, chaotic fluctuations in the fabric of space-time. Do you find the idea of quantum fluctuations unsettling? Or does it open up a whole new way of thinking about the universe? Time after death. When we consider the concept of time, we often think of it as a linear, unending sequence. A constant progression from the past to the future, measured in seconds, minutes, and hours. But what happens when time intersects with the end of life itself? What if time, as we experience it, doesn't truly end with death? This concept, time after death, is something that has intrigued philosophers, scientists, and mystics for centuries. In the physical sense, once the body ceases to function, time, as we know it, seems to stop. Yet, does time continue in some form even after the body has ceased its motion? Or does time itself dissolve along with life? The perception of time after death. One fascinating perspective is that, in a certain sense, the perception of time may continue even after death. According to various near-death experiences (NDEs) documented by those who have been clinically dead and revived, many individuals report a sensation of timelessness, or even a feeling that time has stopped completely. This perception of an infinite, boundless existence could suggest that our experience of time is intrinsically tied to the biological processes of the brain. When the brain ceases to function, so does the ability to measure time in the way we are accustomed to. However, there are theories that propose that consciousness might not vanish. at death. This would mean that time, as experienced by the conscious mind, could continue in a different form, outside the limits of the body and brain. Cosmic time and the end of life. But there's also a more cosmological view. Just as individual lives have a beginning and an end, so too does the universe. What happens to time when the universe itself eventually collapses, as it will according to certain theories? If time is tied to the very structure of the universe, could time itself cease to exist in a meaningful way once the universe has reached its final stages? Some cosmological models suggest that time could be intertwined with the fabric of space-time, and if the universe undergoes a cataclysmic collapse, time might not just stop, but stretch and bend into a state we can't even fathom. Just as the concept of the Big Crunch predicts a collapse of space itself, the ultimate death of the universe could mark the end of time in any recognizable form. Theories from physics. Some theories of quantum mechanics also propose that time may not be a constant, but something that can be altered or even exist in multiple dimensions simultaneously. In this view, time doesn't necessarily end with death, but rather moves through different planes of existence. Could our own passage through life be merely a small part of a much broader time frame? Could there be other times or dimensions where the concept of time is fundamentally different? Moreover, in the realm of black holes, where time bends and warps due to immense gravity, the end of life or the end of the universe could take on entirely different meanings. If time behaves so differently near a black hole's event horizon, could there be places where time is more fluid, where it continues on in ways we cannot understand? Life beyond time. Religious and spiritual traditions also add their own layer of mystery to this idea. Many suggest that after death, our souls enter another plane of existence, where time no longer operates in the way we know it. This could imply that death is not the true end of time, but rather a transition into a realm where time is an entirely different concept, possibly irrelevant altogether. According to many spiritual beliefs, time is merely a construct of the material world, and in the afterlife, time itself may cease to be meaningful. What does this mean for us? The idea of time after death raises profound questions about the nature of existence. If time as we experience it ends with death, what happens to our consciousness? Does it experience a timeless eternity, or is it simply removed from the flow of time? Understand within our limited, time-bound lives. Have you ever wondered about time after death and how it fits into your own life? The Boltzmann Brain. The Boltzmann Brain hypothesis is one of the most unsettling ideas in the realm of cosmology, shaking the very foundations of our perception of reality. It suggests that in an infinite and chaotic universe, the likelihood of a conscious brain forming from random fluctuations of particles is statistically higher than the creation of a stable, ordered universe like the one we know. The idea posits that, at some point in the farthest reaches of the universe, particles may spontaneously assemble to create a fully functioning brain, complete with thoughts, memories, and consciousness, yet with no connection to anything around it. This brain would have no history, no external context, and would exist solely in a brief, random moment of consciousness. To make matters worse, this random, isolated consciousness would have no continuity, no relationships, no meaning beyond its fleeting existence. It would essentially wake up in an empty, lifeless void, with no recollection of how it came into being or how long it will last. The true horror of the Boltzmann brain is the possibility that the universe we experience, this ordered, structured reality, could be the statistical anomaly, while the true nature of existence could be one of randomness and nothingness. This hypothesis challenges our fundamental understanding of existence. It forces us to confront the uncomfortable idea that everything we perceive as real, the stars, the galaxies, even ourselves, could merely be a temporary fluctuation of particles in the vast chaotic emptiness of the universe. In a universe governed by entropy and the laws of probability, it's conceivable that we could be nothing more than a brief, fleeting fluctuation in an infinite sea of chaos. This means our entire reality, with its seemingly stable laws and structures, could be just a random event in the grand scheme of an unfeeling universe. What was even more mind-bending is that the formation of a Boltzmann brain would have no purpose, no design, and no plan. It's not as if the universe consciously chose to create our minds or our experiences. It's simply the product of statistical probability. The brain that wakes up wouldn't have a past or a future, only a momentary awareness before it vanishes back into the chaotic void from which it came. The idea that we could be nothing more than random, disjointed consciousness in a cold, meaningless universe is a truly unnerving thought. The implications of the Boltzmann brain theory are staggering. If our universe, with all its laws of physics, life, and structure, is just an improbable arrangement of particles, then what does that say about the authenticity of our experiences and our sense of self? Are we truly experiencing the universe as it is, or are we simply a random product of chance, a cosmic accident that has briefly gained consciousness? The mind-bending aspect of this theory is that it challenges the very essence of who we are and what our existence means. It forces us to ask, is our reality genuine, or is it merely a temporary, random blip in the eternal chaos of the cosmos? If you're feeling unsettled by the Boltzmann brain hypothesis, you're not alone. The thought of being nothing more than a statistical anomaly is a deeply unnerving concept, but it also serves as a powerful reminder of the limitations of our knowledge and the vast mysteries that remain beyond our comprehension. As we continue to explore the mysteries of a universe, let us remember that we are just one small part of an infinitely complex and chaotic system. What do you think about the idea of the Boltzmann brain? Could it be possible that we're all just random, isolated moments of consciousness? Or is there something deeper and more meaningful at the core of our existence? Rebirth of the universe. As we dive deeper into the cosmos and contemplate the ultimate fate of everything, one particularly intriguing and somewhat hopeful concept is the idea of the rebirth of the universe. Imagine, after the universe reaches its ultimate end, after entropy has taken its toll and all matter has dispersed into the void, a new universe could arise from the ashes of the old one. This theory suggests that the universe could be cyclical, forever undergoing cycles of destruction and creation, a cosmic phoenix constantly reborn from the death of its previous self. One of the most fascinating aspects of this idea is that it allows for the possibility that the universe as we know it could be just one iteration in a never-ending series of universes, each arising from the ashes of the one before. This concept challenges the traditional notion of a linear, one-time universe that began with the Big Bang and will end in heat death or some other ultimate conclusion. Instead, it envisions a universe that is eternal, not in a static sense, but in a constantly evolving, self-renewing cycle. The rebirth of the universe could take place through a process called the Big Bounce, a theory that suggests the universe undergoes a cyclical series of expansions and contractions. After reaching a point of maximum expansion, the universe could eventually collapse in on itself, triggering another Big Bang and starting the process all over again. This theory could explain why the universe appears to be fine-tuned for life in the first place. Perhaps the universe's constants have been reset time and time again, giving rise to the perfect conditions for the emergence of life each time. But how would the universe be reborn, and what would this new universe look like? Would it be exactly the same as the previous one, or would the forces of nature shift in unpredictable ways, giving rise to a reality completely different from the one we know? Imagine a universe where the laws of physics are slightly altered, or one where the fundamental forces operate in a completely different manner. What if, in each iteration, life and consciousness evolve in ways we can't even begin to fathom? The concept of rebirth also brings into question the nature of time itself. If the universe is indeed cyclical, does time repeat itself, or does it evolve into something entirely new with each cycle? Could there be an infinite series of universes, each one gradually shifting away from its predecessor until it reaches a completely different state of existence? The cyclical universe theory challenges our linear perception of time and pushes us to rethink our place in the cosmos. It opens up the possibility of an endless dynamic flow of time, where each end is merely the precursor to a new beginning. In a way, the rebirth of the universe offers a glimpse of hope amid the seemingly inevitable doom of cosmic entropy. If everything is destined to eventually collapse, the notion that the universe could be born anew suggests that the cycle of existence is not merely an endless void of death, but a process of perpetual transformation. The destruction of one universe could lay the foundation for the creation of another, where the cycle begins once more life, death, and rebirth in an eternal cosmic dance. What's even more unsettling, though, is the idea that in the vast expanse of time, the universe's rebirth may go unnoticed, forever cycling without any conscious observer to witness it. If the cycle of rebirths continues infinitely, each iteration of the universe would essentially be a brief, fleeting moment in the grand scheme of cosmic history. The beings that inhabit these universes would have no memory of previous cycles, forever unaware of the grand cosmic drama unfolding around them. As we look up at the stars and ponder the future, the idea of the universe's rebirth invites us to think about our own existence in a new light. Are we merely a temporary flicker in the eternal flame of the cosmos? Could the universe, in its endless cycles of life and death, be offering us an ultimate lesson in impermanence and renewal? So what do you think? Could the universe actually be reborn after its eventual death, leading to new cycles of existence? Or is the idea of rebirth just another philosophical exercise to make us feel better about the inevitable end? The silent observer. As we continue our journey into the mysteries of the universe's fate, we encounter one of the most chilling and mind-bending concepts: the silent observer. This idea suggests that, as the universe slowly winds down, collapsing into a state of entropy, there might be a silent, impartial force or entity that watches over the entire process. It doesn't interfere, doesn't intervene, but instead observes the infinite cycle of life, death, and rebirth that takes place within the vast expanse of existence. The silent observer could be interpreted in a variety of ways, depending on your perspective. From a scientific standpoint, it might represent the laws of physics themselves, constantly at work in the background, silently maintaining the balance of the cosmos. These laws, gravity, electromagnetism, quantum mechanics, continue to operate and govern everything, from the smallest particles to the largest galaxies, regardless of whether anyone is there to observe them. It's as if the universe operates on autopilot, playing out its cosmic drama without the need for an active audience. But what if the silent observer is not just an abstract concept, but an actual conscious being, one that has transcended the limitations of time and space? In this interpretation, observer may be a godlike entity, a being of unimaginable power, who watches the universe unfold without ever directly influencing it. Perhaps it is a timeless, sentient entity that has seen the birth and death of countless universes, watching with detached curiosity as each one plays out its cycle. This figure would be entirely separate from the universe, yet intimately tied to it, as if it were both part of the whole and apart from it at the same time. In some ways, this concept calls into question the nature of observation itself. If there is no one to witness the events of the universe's end, does it still matter? Does the universe continue on its path to collapse? Or is its very existence contingent on an observer being present to give it meaning? Some theories in quantum mechanics suggest that the act of observation itself influences the outcome of events, as seen in the famous double-slit experiment. If no one is there to observe the universe's final moments, would it truly have any significance? Or would it simply fade into nothingness, unremarkable and forgotten? The silent observer also raises intriguing philosophical questions about the nature of existence. If the universe is meant to be observed, and if the observer is silent and detached, what does that say about our own role in the grand scheme of things? Are we the active participants in the cosmic drama, or are we just passive observers, unknowingly playing out our roles in the vast empty theater of the universe? The silent observer implies that, in the end, we are but fleeting moments in an eternal cycle, observed but never fully understood. In a more existential sense, the silent observer could represent our own internal experience of life and death. We may go through our lives unaware of the cosmic forces that shape us, as if we are all silent observers of our own existence. From this perspective, we are both the observed and the observer, watching the world unfold while remaining largely unaware of the deeper, more intricate workings of the universe. This idea may seem unsettling, as it suggests that we are part of something far greater than ourselves, yet so distant from it that we may never fully comprehend it. As we ponder the silent observer, we're faced with the reality that the universe might continue its inevitable path to the end, regardless of our awareness. Yet perhaps it's this very silence, this absence of an active observer, that gives the universe its true beauty. The idea that everything can unfold on its own, without a guiding hand, can be both terrifying and liberating, forcing us to reconsider our place in the cosmos. So, what do you think? Is the silent observer a powerful cosmic entity, or is it just the cold, indifferent laws of the universe at work? Nothingness isn't empty. As we reach the final stages of our cosmic journey, we must confront one of the most perplexing and profound concepts. Nothingness isn't empty. The idea that nothingness, the absence of everything, can somehow still have substance, meaning, or even properties, challenges our most fundamental understanding of reality. At first glance, nothingness might seem like a straightforward concept, an absolute void, the absence of all things, a blank canvas devoid of matter, energy, or even space. But when we look deeper, this seemingly empty void becomes much more complicated. According to modern physics, especially in the realms of quantum mechanics and cosmology, nothingness is far from empty. In fact, empty space, which we often refer to as a void, is actually teeming with activity. In the quantum realm, even in the most seemingly empty space, virtual particles spontaneously pop into existence and then disappear again in the blink of an eye. This phenomenon, known as quantum fluctuations, suggests that what we perceive as emptiness is actually full of potential, energy, and activity. It's as if the void is alive, constantly shifting and vibrating with unseen forces, waiting for the right conditions to bring something into being. The concept of nothingness being full also challenges our understanding of the very fabric of reality. Some theories suggest that the empty space between stars, galaxies, and other cosmic objects might not be empty at all. Instead, it could be filled with dark energy, a mysterious force that is driving the accelerated expansion of the universe. In this sense, nothing between objects is actually a powerful and active force, shaping the cosmos in ways we are only beginning to understand. This idea leads to even deeper philosophical questions. If nothingness isn't truly empty, then what does it mean for the universe's ultimate fate? Could it be that, even in the end, when all matter has been exhausted, when everything has collapsed into black holes and the last stars have burned out, The nothingness that remains is still filled with something, some form of energy, some essence that continues to exist, even if we can't detect it. Is the universe's end really the end, or does something remain in the emptiness? The concept of nothingness being full also forces us to reconsider the nature of existence itself. If what we think of as nothing is actually something, how do we define existence? Is existence merely the absence of non-existence, or is there a deeper, more fundamental truth to what is empty or full? Some philosophers argue that nothingness, far from being a simple void, is a source of infinite potential, a state of pure possibility where anything could arise. This suggests that even when everything is gone, the potential for something to emerge from the void remains, waiting for the right moment or the right conditions to bring it into existence. Furthermore, this idea hints at the cyclical nature of existence. The universe may have arisen from nothing, and when it eventually fades into oblivion, it may simply transform into a different form of nothingness. It's a cycle of creation and destruction that might play out infinitely. Nothingness, then, is not a final destination, but rather a continuous state of flux, a dynamic force in its own right. The question of whether nothingness is truly empty also plays into the idea of eternal recurrence, the belief that the universe is destined to repeat itself in an endless cycle. If nothingness is not empty, if it is full of potential and energy, then the end of one cycle might simply give rise to the next. Perhaps nothing is ever truly lost, and everything that has ever existed will eventually return in some form. So, as we approach the end of this exploration, let us reflect on the nature of nothingness. Is it truly empty, or is it a dynamic, living force that holds the potential for everything and nothing, all at once? Could the universe itself be an endless dance of creation, destruction, and rebirth, all rooted in the very essence of nothingness, when all light fades? As the final chapter of the universe's journey unfolds, all light fades into oblivion, marking the ultimate moment of silence and stillness. In the absence of light, everything that once flourished in the cosmic dance, stars, planets, galaxies, disappears into the void, leaving behind nothing but cold, dark emptiness. Light, which has always been a symbol of life, energy, and understanding, slowly extinguishes as the universe marches toward its inevitable end. This moment is far more than just the death of stars. It's the death of everything that once existed, from the smallest atoms to the largest galaxies. As the stars flicker out one by one, their light no longer guides us, and the cosmos becomes a vast, uninhabited stretch of nothingness. It is a silence so profound that even time itself seems to lose its meaning. The once vibrant pulse of the universe, fueled by the energy of billions of stars, becomes a still, lifeless expanse. The galaxies, once majestic and filled with cosmic activity, become nothing but memories, fading into the abyss. Yet, the absence of light doesn't just mean the end of the universe as we know it. It also signals the death of consciousness and perception. Light has been our way of understanding the world around us, allowing us to explore, to learn, and to experience life. Without it, we are left in complete darkness, unable to see, to feel, or even to comprehend the vastness of space. The very foundation of existence crumbles, leaving behind an endless stretch of silence and coldness. But in this darkness, something remarkable happens. The universe, in its final breath, holds all the knowledge of everything that came before. Every star that has ever shone, every galaxy that has ever spun, is now a part of this great cosmic archive. Even though there is no more light to guide us, the memory of what once was remains embedded in the very fabric of space. Perhaps in this silence, the universe itself is contemplating its fate, slowly preparing for the next great transformation, or perhaps it's surrendering to the void in an eternal, irreversible stillness. In this final moment, the universe is both an enigma and a reflection of everything it has ever been. It is both a place of infinite potential and a barren, empty expanse. Its past is full of violent explosions, stellar births, and galactic collisions. But now, it is a place of deep stillness. The void is not truly empty. It is rich with the echoes of everything that has occurred, and it is in this profound silence that we confront the greatest mystery of all, the ultimate fate of the cosmos. In this moment of pure darkness, we are forced to confront the most profound questions about existence. Is the end truly the end, or is it a gateway to something else? The universe, in its infinite expanse, has undergone countless transformations. Stars have been born, lived, and died. Galaxies have collided and merged. And now the universe itself is winding down, returning to a state of pure stillness. But in this stillness, is there more? Can the universe regenerate, or has it reached a point where it is beyond the reach of rebirth? Perhaps, in the absence of light, we will find the truth. Will this emptiness give rise to new life, as the death of one cycle becomes the birth of another? Or is the silence, the fading of light, the final punctuation at the end of a never-ending story? Is the fading of stars the ultimate surrender of everything that ever was? Or does it mark the beginning of something we cannot yet comprehend? Will the universe be reborn in a different form? Or is this the quiet conclusion of all that was ever created? And as the last spark of light disappears, will the universe simply collapse into nothingness? Or is it possible that the very fabric of space and time will stretch infinitely beyond the horizon of our understanding? In this moment, where everything we know dissolves into nothingness, is there still room for something greater to emerge? As you contemplate the fate of the universe, let us know what you think in the comments. Do you believe that the fading light signifies the end, or is it merely a step toward a new beginning? What does the universe's final transformation mean to you?